warm welcome to the session. Today's topic is about surface areas and volumes. So actually it is a voluminous chapter only. We have many concepts to explain to the students and n number of questions are there to be discussed and at least 3 to 4 questions in each type to be discussed so the children will be comfortably face this chapter surface area and volumes. And also, and this chapter children find it as very simple only. Why is it so? Why do you think like that? Usually children like this concept, like this chapter.
Because
Why do you
while
think?
explaining those things, while talking about the shapes, mostly we
Yeah,
engage with real-time examples like
yes,
the cone and other things. They will be very excited.
right. Since we are dealing with the shapes, right, and they are seeing those shapes in the real life scenario, so they like the chapter because they're experiencing those things. Since they're experiencing, they're able to engage in it, so easily they can understand the concept. Even though they understand the concepts well, okay, they are able, suppose if you take the combination of the solids, they're able to frame the formula and they can write the formula also if they understand the derivation of the formula and they can properly apply the formula. Then they have to simplify and then plug in the values. After plugging the values, the simplification and the calculation part. And those things, many of them finding it very difficult, right? Simplifying the formula derived and that formula, we have to plug in the values and the simplification of that expression and then calculation and getting the answer. So the children, most of the times they are finding it very difficult and we have to spend more time in the calculation part, I feel. If they see the decimal numbers or the fraction numbers, immediately they don't know how to further proceed the questions. So there and all, we have to help the students even though they are in the class 9th and the 10th grade, I feel. Right. And moreover, since they are visualizing the solids and this chapter, it would be easy to them. They are able to understand the derivation. They should understand the derivation such a way we have to clarify the concepts and we have to proceed it. Right? So now, the first thing we have to make them to understand when they come from class 8 to class 9, surface area and volume. So many of the students, they don't know to distinguish between the surface areas and volume and attributes and their measurements. For example, if I show this pen, so what would be the appropriate units I have to use for this? So I can measure this pen using the centimeter or inches. So like that, children, they're not able to, many of them are not able to give the appropriate units to the whatever the things we are showing. So first, we can use some questions like this. It is called as the diagnostic assessment. Please note the point. There are many different assessments are there, and this we call as a diagnostic assessment. Why I am telling this diagnostic assessment means this is the pre-assessment. Okay, so we are just checking their knowledge to continue our teaching concepts, to continue our teaching learning to how to deliver this lesson. To understand how to deliver this lesson, we can conduct the small pre-assessment test. It is called as a diagnostic assessment. So once they come from the class 8 to 9, when we start the session, we can give this assessment to understand their strength, weakness, their knowledge and skill about this concept, about the surface area and volume. So if we understand that, we can proceed our class 9 concept because most of them here we used to teach a class 9 and 10. So when they come from the class 8 to class 9, completely all the students are new to this. So we don't know what about their knowledge about the surface area and volume. So to understand that, giving this pre-assessment, I think it is required. Okay, that is called as a diagnostic assessment. Note the point. Okay, so I have taken the few questions here, quantities and the corresponding units. So for each quantity, children to choose one or more appropriate units of the measurement. Suppose if we take the perimeter of a parking lot. So what could be the appropriate units? Parking lot perimeter. It could be in meters.
In meters, maybe. In
Or in
meters.
the feet. Even the feet also, it could be. Volume of the symmetric. So volume means immediately they have to catch a cubic, right? So volume of the symmetric. Could you give the answer? Symmetric.
Volume of symmetric cubic meters.
Meters. It cannot be cubic kilometers. Only the huge
Yeah,
volume we have
obviously.
to go for the cubic kilometers. Symmetric, so we can go for the cubic meters. And surface area of the refrigerator, we can go for the, it's like a, just we are interacting, that's it, okay? You could give the answer. Surface
Square,
area of the refrigerator.
square
Yes.
meter, maybe square square feet
Square
or square
inches.
meter.
We can go for square inches. Sometimes we
Okay.
can go for square feet also, nothing wrong. And length of an eyelash. Eyelash,
Millimeter, obviously it might
millimeters.
be very small.
Yeah, it's very, very small. So we can go for the millimeters, right? Area of a state. Area of a state or country, like that.
Square
Square,
Kilometer.
kilometers. Square
square
kilometers.
kilometers, right? Square
Yeah.
kilometers. Like that, we can do the activity. Volume of an ocean.
Cubic
Volume.
kilometers.
Yes,
It's
cubic
vast.
kilometers. Yeah, it's a huge thing. So we can go for the cubic kilometers, right? Area of the land.
Square
Area
feet.
of the
They
land.
used to say square feet.
Square meter. Square kilometer.
Feet. Yeah, if it is a small area, then we can go for the square feet, or
It's a
square
big
meters, we can go it,
Oh.
right? So usually in Tamil Nadu, they'll use a square feet to measure the area of the land. But if you go for the Andhra, they might be using the square meters.
meter.
Yeah. And they have to give some quantity for the kilometers. So kilometers, what could be the correct quantity? Kilometers. I could suggest your distance between the two places, right? Distance
Like
between the two
meter.
places. Then distance between the two places. Some other examples for the kilometers. So what we would measure in terms of the kilometers? What quantities?
Distance between two cities,
Two cities, two places,
two places.
length of the road, right? Length of the road we used to measure in the kilometers. Yes. Cubic meters, other teachers, come on. Cubic meter. Cubic meters. Could you give some examples? Cubic meters.
Like
Cubic
volume
meters.
of, if I'm measuring a milk or something in a volume, might be cubic meters in a large
Measuring
tank.
the milk in a container, bigger container like
Yeah,
that.
contain. That's
Or
large.
we can say amount of air present in the room, amount of air present in the auditorium. So like that, we can give example for the cubic meters. Please test this teachers, okay? Once they come to the class 8 to 9, whether they are able to choose the appropriate units for the given quantities. This would be really very helpful for us to go about our chapters. So how we have to deliver the concept, we will get some idea. So once we have to understand the strength and the weakness of the students, we can proceed our concept. Then this also the other activity, we can give this also to understand whether they know the volume and surface area properly. So in our Max Lab, cubes are very well available. So using the unit cubes, ask them to do the different shapes. So you give the 16 cubes to them, make them to understand they have to do the two different shapes using the 8 cubes for each. So for the shape, whatever they have brought it, they have to find the volume and surface area. So like that, we can give some activities. Then this please test, okay? So two figures can have the same volume, but different surface areas. So this part we have to make them to understand, and also it will be very helpful in their Prajna examination, Olympiads. Olympiads and all, if you see many questions based on the unit cubes only, they are given, right? So if we see here, I have taken the two polyhedrons. So using the 4 cubes, two different shapes have made here. So both are the prisms only. In the both rectangular prism, the first one having the 4 cubic units, right? Second one also having the same volume, 4 cubic units, having the same volume here. But what about the surface area? If you see the surface area of this one, so in this all 4 cubes, 2 faces are hidden, right? So 2 faces are hidden. So the hidden face must be known to the students. So if you give the activity like this, they can understand what are the faces are the hidden, how many faces are visible. So from that, they are able to understand the surface area. So in each cube, they are able to see the 4 faces. That means 4 faces and 4 cubes are there. So 4 into 4, 16 square centimeter is the surface area. Whereas the second one, in second rectangular prism, here also having the same volume, 4 cubic units. But if you see the surface area of this, so surface area here is the, in the inside the 2 cubes, they're able to see only the 4 faces. Whereas the first and the last, both the ends, in the 2 cubes, they're able to see the 5 faces. Right? So here 4, here 4, here 5, here 5. So totally they are able to see the 18 faces. Therefore, surface area is 18 square centimeter. Like that, we can do small activity. It would be helpful for them to face the aptitude examination also, and also we can understand whether they know the what is surface area and the volume for the given prisms, right? And again, we have to make them to understand, even if they have the same surface area, they may have the different volumes also. So for that, we have to give some examples. I have taken the 2 prisms here. So one with the 5 cubic units, other with the 6 cubic units. So here they have the different volumes, but both of them having the same surface area. Isn't it, teachers? Same surface area. What about the first one, surface area? How many square units are here?
First cube might have 5 face, then it's 5, 4.
Yeah, 5, 4, 4, 4, 5.
10,
Yeah, so totally it has
22.
22 square centimeters. Right. And can you find for this, the second one?
4. All the 4 corners will have 4 faces. 4,
Yeah,
4,
4 corners having the 4 and the middle one
3.
having 3.
3 and 3.
So here the totally
20. No, I'm sorry. 20.
same,
22.
16 plus 6, 22.
22,
Right?
22.
So
Yeah.
both having the same surface area, different volume. This is possible, we have to tell, my dear teachers, okay? So we can frame, we can make the cubes, that is make the different polyhedrons having the same surface area, different volumes. Same volumes, different surface area. It is possible that we have to do it. In class 7 level, we used to do with the same area, different perimeter, same perimeter, different area. So that kind of the activity we used to do in the class 7. In the class 9 level, if you introduce this would be very much helpful for them to face their Pragya examination and the aptitude examination. Then clearly we have to give the examples for the surface area. So the definition here, it says surface area of a polyhedron is the number of square units that covers all the faces of the polyhedron without any gaps or overlaps. We can do like this. Otherwise, our general way of telling about surface area, it is nothing but the sum of the area of the faces bounded by the given solid. Whatever the solids we are having, and we have to add all the area of the faces bounded by the solid. Like that also we can do the definition. But not only this, we have to get the many examples. Okay, children should try to tell. Can you give some examples for the surface area and volume? When we have to find surface area, when we have to find volume, means they should tell some examples. So what are the examples they could say? Suppose if I want to paint the 4 walls of my room, then I'll be finding the surface area of the walls, isn't it? Suppose if I want to find how much air present in my room, means I have to go about the volume of the room. So like that, they have to do n number of the examples. Suppose I want to make the cuboidal box. That means I have to find the surface area so that I can find what is the area of the sheet required to make it. Suppose I want to make the tent. So how much cloth required, tarpaulin cloth required to make the tent, means I have to do the surface area. Like that, first, before we start the concept, we have to make them to understand what is surface area, what is volume, by giving more examples, and they should also give more number of the examples. After giving the complete clarification about the surface area and the volume, the distinguish between it, then only we can proceed for the derivation of the formulae. Right? So next we'll go for the volume. So volume they have to understand like this. Volume is the number of cubic units that fill a 3-dimensional region without any gaps or overlaps. Otherwise, you can just give the solids like this using the unit cubes. Then we can ask them, what about the volume of this? So children, they have to see first layer. So in first layer, there are how many cubes? 5 into 4, 20 cubes. 20 cubes are there in the first layer, second layer also 20 cubes, third layer also 20 cubes. So totally 60 cubes are there. Therefore, the volume is 60 cubic units. So like this, we can give some examples because cubes are very well available in the lab. So we can utilize those things and we can help the children, and the clarity should be given between the surface area and the volume, right? So one more practice question I have taken. So this also, there are many practice questions have taken for the diagnostic assessment. You can take any one and tell to the students and see what about their strength and weakness about the surface area and the volume. If you see this question, I have taken the 4 cubes and the 4 cubes, unit cubes I have taken, 4 cubes I have stacked one over the other. So ask them, how will you find the volume of the figure? So finding volume is very simple to them, right? So what about the volume here?
4 cubic units. 4
cubic units, right? So 4 cubic units. What about the surface area? Surface area of this. They can count and tell it. Otherwise, they can use the cuboid formula, length 1, breadth 1, height 4, anything. Because 8 to 9, already 8, we introduced the surface area and volume of the cube, cuboid and cylinder. Yes?
It's 18.
So here they can see 5, here they can see 5, and in between they can see 4, right? So 18. So 18 square units.
Because we are counting the number of squares.
Since I told it is the centimeter cube, then we can say 18 square centimeter. Then try to ask this question, how they are answered. Okay. If we double the number of cubes being stacked, both the volume and surface area will double. What is your idea about this? So if we double the number of cubes being stacked, both the volume and surface area will double. True or false this statement? Please pose this question and see about their knowledge. So surely they can tell about the volume. Isn't it? Volume is very simple.
It's easy actually.
Yes, 8 only. So suppose if we stack 4 more cubes on this, so they can tell very clearly volume is doubled, 8 cubic units, right? But what about surface area? Is it doubled? Is it double when we add 4 more cubes on this cover?
No.
No, right? So what would be the answer? The answer is?
Probably 18 plus 18, 30, 35.
8, right?
35.
So
one phase will be merged with another phase. It might be 35.
8 into 4, 32. 32 plus 2, 34. Right? Because 8 cubes are there. In the 8 cubes, they can see the 4 faces. But the top and the bottom, they could see the 5. Right? So we can just take 8 into 4, 32. And add the top face and the bottom end face. Top face and the bottom end face plus 2. So 34. So it is not doubled. Right? So 18 into 2 is 36. It is not doubled. Why is it so? Means because the faces are hidden here. So in between, totally we have the 8 cubes. The 8 cubes, for the between 6 cubes, 2 faces are hidden. Only for the top and the bottom face, they are seeing the 5. So here it won't be double because of the 2 faces hidden in the middle cubes. Only for the top and the bottom, they are able to see the 5 faces. Like this, we can show the cubes, we can tell them it is not double. Only the volume would be double. Surface area will not be double when we stack the cubes like this. Right? Because of the hidden faces. The hidden faces concept should be shown here and they have to understand here so that comfortably they can work with the combination of the solids about the hidden faces. Right, teacher? Shall we proceed with the next one?
Yes, ma'am.
Yes. Yeah. So now this we will discuss. We all do as one small activity. Every one of you, please participate here. All the teachers, just one small activity. Vinu said 2 figures with the same volume also have the same surface area. Okay, she said two figures with the same volume also have the same surface area? Yes, it's possible. We have seen few things. Same volume, different surface area. Same surface area, different volume. But it is possible same volume with same surface area also. So could you suggest which two figures suggest her statement true and which two figures could show that her statement is not true? So why we have to bring these things means when we understand with the cubes, when children understand the things with the cubes, easily they can build the concept and they can visualize it, they can explore the level of thinking. And most of the time, if you see about the aptitude level of the questions, they would be asking the questions like this. Isn't it, teachers? We have seen the many Olympiad question papers, Pragya question papers, right? So working with this kind of the questions. Yes? Shall we do it? Yes, we'll all together do this question. So we have to identify the two figures where the volumes and surface area sync. First, we will reject it. We'll ask the student to reject it. It's very, very important. Rejection done means we'll be having the less choice so that easily we can select the correct thing. So first we'll see the volume and we'll reject something.
Yeah, ma'am. First, now counting the number of cubes, we can eliminate two options. Then we can compare other three.
Right, right. You are right, ma'am. Yes. So what we could eliminate here, I think we can eliminate this D and D.
D and E.
D and E.
Yes, because D has how many cubes?
D is having
Having 5, ma'am.
Seven. D.
Seven.
D.
D is 7, ma'am. E is 5.
Yeah, D 7 cubes, E 5. And A, B, C 6 cubes, right?
Yes, ma'am.
Yeah. So we want the figures with the same volume and same surface area. Since we want the same volume, same surface area, we'll see with A, B, and C. Yeah, teachers. Children like this. We can do some group activity. Surely they will enjoy. They bring the new, different kind of the polyhedrons. And these materials are available in our Maths lab. We can fix the cubes and we can show it to them. Yes. Just see how many faces are seen. Like that, we can help the students. How many faces are seen that they can write and they can do it. Suppose if we take B, here I can see 5, right? Here also I can see 5. Isn't it, teachers? Here, this corner, how many are seen?
4, ma'am.
Yes, 4. Here also 4. Right. And here, this one? 3. Oh, sorry. Yeah, here 3. And we have at the back, no, the bottom at the last. This one.
That is also 3.
That is also 3. Right, that is also 3. So totally how many could you say? So 10, 18, 18 plus 6, 20, 22, right? Now see how many? First ask the students to tell about number of faces seen. Number of faces seen. Here 5, here 5. It is seen, right? And here, this one is, you can see the 4, right? And even the bottom one also, 4 is seen. Will you agree? Will you agree? Children, they have to visualize.
Then it's 3.
And this is 3.
This also 3.
Right? And here also we have same 22.
We can even ask them to reassemble and then assemble again and then count the number of cubes and do things like that.
But
Small
according to the
cubes are
question,
also...
they can't reassemble.
No. After giving the question,
yes,
we can give them some idea about reassembling and finding out and then coming back.
Yes, ma'am. Yes. So after that, they can reassemble, they can find a new different arrangement of the polyhedron and the surface area and the volume. Right? So for the first one, which two figures suggest that her statement is true means having the same volume and same surface area? B and C is the answer. So like this, we can give some activities. Children will participate in that. They will enjoy also. And we can sharpen their skills. So visualizing the things, right? Whatever the hidden cube. So they can visualize and they can bring the ideas about this also. Yes, teachers? And which two figures could you show that a statement is not true? So not true means same volume, different surface area, or same surface area, different volumes. So for that, we can choose A and D, right? A and D having the different volume and different surface area also. Isn't it, teachers?
Yes, ma'am.
Yes, ma'am.
Is it interesting or feeling? How do you feel, children? Children entering? How do you feel this? So like that, we can give some activities, right?
Yeah, ma'am. By taking the cubes in the class itself,
Yes.
we can make them to arrange, and it will be more lively. We can make them more interactive. Nice.
Make the class more lively by giving some sort of these activities, ma'am, than having a monotonous way of teaching.
Yes, ma'am.
In case that there happens to be something like in the afternoon session, you know, we can tell them. In case it happens to be an afternoon session class, we can give such small activities. Supposing it happens to be the last period class.
And substitution, ma'am. Substitution classes.
Yeah, exactly. During substitution
We can
classes.
do this.
Just to get some, you know, a sort of interest towards the subject.
We used to have gift box, right, ma'am? A small box like that. So if you have to take a huge box, and I used to paste white paper in all the sides to make a cube, and I used to make a dice over that. So we can throw it in the class to any of the students. What's the number you got? So they will be very excited. Ma'am going to throw it to me, towards me. So instead of making a small dice, if you make a big dice and if you throw all over the class, the probability we can make it more fun actually.
All could see the die also instead of throwing the small.
They can see the number
make
of
it like this. Yes, you are right. That would be very interesting. We can do it for substitution classes. Okay, instead of sitting and making them to do some other work.
Either in substitution classes or in classes when you come across in the last period.
Yes, ma'am.
During last period sessions, they won't be willing to listen to monotonous calculation type of questions. At that stage, we can give them such simple activities which will make them develop some interest towards the subject. That's it.
Right, teacher? Shall we proceed to the next one? Yes. Shall I proceed the next slide? Right. So like that. So this we call as the diagnostic assessment, pre-assessment tool. So once the children they are able to understand this means like that we can proceed our further level of the concepts. Right. So now the next one, the derivation. So derivation must be done for all the solids teachers. Okay, we should not skip it. They have to understand it, all the derivation, how we are getting the formula. The formula should not be memorized. If they understand it, they themselves write the formula. They themselves create the formula, right? So first one, we have the cuboid. Cuboid surface area, we can make them to understand by using the net, right? So we can draw the net for that, or if you are able to unfold the cuboid and we can show the net. So whatever the things possible, we can do it. So we have to make them to understand the surface area of the cuboid is 2LB plus BH plus HL. So like that we can do with the net of that. And lateral surface area. What is the lateral surface area? So leaving the top and the bottom faces, we have to consider the all side faces. So we have to find surface area of the all side faces. So like that we can take that and we can tell them what about the left side. Left side here is the BH. BH is the left side. And the left and the right both are the congruent faces. So they have BH as the area. Then the front and the back face. So front we have L into H. And back also is having the same L into H. Therefore the formula is 2LH plus 2BH, taking 2H common, 2H into L plus B. So like that we have to make them to understand. And also my dear teachers, please tell them this. They have to visualize the lateral surface area by using the perimeter of the base rectangle into height. So what we can tell them means take a string. Okay, that string you have to rebend and make it as a rectangle. Like that, take the congruent rectangles, stack the rectangles one over the other. What you would be getting? So they may tell that we would be getting the four sides of the cuboid. So we can get the lateral surface area of the cuboid by using that the base perimeter. The base perimeter is the 2 into L plus B. So we are stacking the 2 into L plus B up to the height h. So the formula is 2 into L plus B into h. That is the perimeter of the base rectangle into height. So when we help them to understand this, like that, we can do it for the curved surface area of the cylinder. Not only the curved surface area of the cylinder, all the prisms lateral surface area, they are able to find by stacking the perimeters up to the height h. So if you bring that concept, okay, finding the lateral surface area of the prisms, and it will be very, very helpful when they do with the case study questions and all. Okay. And similarly, the next one, finding the volume of the cuboid. So volume of the cuboid, stacking the rectangular paper. So stacking the congruent rectangular papers up to the height h. So they can say base area into height. That is the volume of the cuboid. So if you see in this explanation, so first they have taken the one stick like that. That length is L units. That stick they are arranging up to the breadth. Okay, the sticks they are arranging on the plane surface. Same congruent sticks they are arranging. When they arrange the congruent sticks next to next, it forms a rectangle. So the area of the rectangle is L into B because they are stacking up to the width B. So they are getting the area L into B when they arrange the same length of the sticks on the floor or on the plane surface. Then that rectangle they are arranging one over the other. So congruent rectangles they are arranging one over the other up to the height h. This gets, from this they can understand the cuboid volume. So base area into height, that is the volume of the cuboid, L into B into h. So first these three things they have to understand: total surface area, lateral surface area, and the volume. Then at the last, not during the concept teaching, at the last, after we complete all the concept, all the exercise problems have done, after that we can go for the finding the length of the diagonal. Okay, when we are doing the extra questions revision time, we can make them to understand how to find the length of the diagonal. So to find the length of the diagonal, first they have to take the base area. In the base area, they have to find the diagonal of the base area. So the diagonal gives the root of L square plus B square. Then the right angle triangle they could take. Right angle triangle is formed. That is the diagonal of the base and then the height h and the diagonal of the cuboid. So it forms a right angle triangle. Therefore, diagonal of the cuboid is root of L square plus B square plus h square. But this formula don't tell when you're teaching the concept at the initial stage. You can tell them, you can help them when you're going for the revision. When you work for the revision of this chapter, that time we can help the students. Suppose if they want to find what is the longest length of the rod can be placed inside the cuboidal room. For those questions, they have to use this formula. So at that time, we can help the students to understand the derivation of the formula. Right? The next one we have here, cube. Similarly, cube also we have to explain using the net. Okay, so we can take the cube and unfold it. We can see the net of the cube. Then all the faces are the congruent square faces. So each area is S square if S is the side of the cube or side of the square. So each face area is S square. There are 6 faces are there, 6 squares are there. Therefore, surface area of the cube is 6S square. And what about the lateral surface area? We are considering only the 4 faces, so 4x square. Like this, slowly we can do the derivation of the lateral surface area and the total surface area of the cube. Even if it's an open cube, how to find out the surface area? Like that, we can ask the question. So the children, they may be told to give the correct answer. 5s square is the answer for the open cuboid. Like that, we can give the n number of the examples. Then the volume of the cube also, we can tell that in the cuboid, if the length, the breadth, height, everything becomes the same, it will become the cube. So LBH, that is equal to S. Then the volume of the cube is S into S into S, S cube. Or stacking also we can help them. Stacking also we can say. So we can take the square sheet and stack the square sheet one over the other up to the height of the S units. Then you will get the cube. Therefore, the volume of the cube is base area into height. Base area is the square. So S into S, S square. And height is also equal to S. Therefore, we can say S into S into S, S cube. Like that we can say. And here also finding the diagonal of the cube. Same way we can proceed, but don't teach the diagonal of the cube at the initial level. When you're doing the revision, that time we can help them to understand the diagonal of the cube. So at the initial level, in the class 9 level, let them understand first total surface area, lateral surface area, and the volume. And then we can proceed for the diagonal at the last. Okay. And then next we have the cylinder. Cylinder, surely we should help the students to understand what about the right circular cylinder and the non-right circular cylinder. Why are we telling that as the non-right circular cylinder? So here the class 9 and 10, we are going to deal only with the right circular cylinder. That to be imparted in the class 9 level itself. Okay. Then finding the surface area of the cylinder. So here also using the net, we have to make them to understand the surface area of the cylinder. When we cut the cylinder along the height wise, open it, rectangular paper would be seen, and the top and bottom is the circular area. So here area of the rectangle is same as the curved surface area of the cylinder, and we have to tell them the circumference that becomes the length of the rectangle and height becomes the breadth of the rectangle. Therefore, 2 pi r is the length and height is the h. So 2 pi r into h gives the area of the paper, area of the rectangle, that is equal to the curved surface area of the cylinder. Like that, please use the net and make them to understand. If it is a total surface area, we have to add the top and the bottom area. They both are circles, so add those areas. Therefore, 2 pi RH plus 2 pi r square. Total surface area is 2 pi r into h plus r. Like that, each and everything you have to understand. And also, when you're working with the lateral surface area of the cylinder, you can ask them to visualize like that. Otherwise, you can take the congruent bangles, right? Congruent bangles and stack bangles one over the other. When we stack the bangles one over the other, we will get the curved surface area of the cylinder. Therefore, CSA of the cylinder is equal to the circumference of the base circle, that is 2 pi r into h. So like that, if we make them to understand, they can work with the all prisms also, the general formula. Yes, ma'am?
We have done that, ma'am. Let me show you. Can you see mine?
Yeah. So yes, ma'am, I'm able to see. Right. Yes, ma'am. You are right. Absolutely right.
We can use this to yeah.
Yes, ma'am. Thank you. Thank you so much.
Thank you, ma'am.
You have shown it. So happy.
Thank you.
Right, ma'am. So like that, we can proceed. And the next one is the volume of the cylinder. So here also stacking the circular region one over the other, congruent circular region one over the other, you will get the volume. Like that, we have to help the students. And we have to introduce about the hollow cylinder because we have one of the questions based on the hollow cylinder in the class 9 and class 10. We have n number of the questions. So what is the hollow cylinder? How to find the volume of the hollow cylinder? So total cylinder minus the inner volume of the cylinder, we will get the hollow cylinder volume, which is pi capital R square H minus pi small r square H. So please take the solid and show to them so that they will experience it, they'll understand, and they can write. They will frame the formula by themselves if we just guide to them. And similarly, total surface area of the hollow cylinder, that is also very important. So please show them the solid and ask them what are the faces you are seeing in that hollow cylinder. They will tell that they could see the outer curved surface, inner curved surface, and the ring part. There are two ring part at the top and the bottom. So inner area 2 pi r h and outer area 2 pi capital R h, and the ring area pi r1 square minus r2 square. We have the two rings, so 2 pi r1 square minus r2 square. Like that, they should bring the formula. Just we have to help them by showing the solid and helping them what are the faces they are seeing. Like this, we have to help the students to understand the hollow cylinder. Right? The next one, cone. So cone, many of them, they are not so comfortable in the cone because they know pi r L and how the pi r L derived, how the derivation, that they are not so strong about it. But please help them. You can take the cone. So take the sector and make them as a cone and tell them here O to B is the slant height L. So this O to B acts as the height in the cone. O to B, this acts as the slant height. This acts as the slant height, we have to say. And the sector, when you open that, it looks like the sector. And we have to cut into the small sector. It's approximately look like the triangle. So area of the each triangle is half into B1 into L. There are n number of the triangles. Actually, it's sector only. But when we take the small sectors, it approximately look like the triangle. Like that, we have till approximately we are taking there. So when we sum up the all triangles, that is equal to the surface area, the curved surface area of the sector, that is equal to the CSA of the cone. So like that, we have to link it. So this B1 plus B2 plus B3 plus B4 up to Bn, that is nothing but the circumference of the base of the cone. That is equals 2 pi r. Therefore, the formula here is half into L into 2 pi r. 2 cancel pi r L. So this should be make them to understand very clearly. And the surface area of the cone, total surface area of the cone, we have to add the base area pi r square. So pi RL plus pi r square, everything by showing the net, we have to make them to understand. When you're doing the volume of the cone, I hope you're all doing this experiment. Right, teachers? Isn't it, teachers? Are you doing this experiment?
Yeah, ma'am. Yeah, ma'am.
Yes, we have to show this experiment. So when you show the experiment, they never ever forget the formula. This cone volume is 1/3 of the volume of the cylinder. Okay, and also we have few questions like this. When you rotate the triangle by illusion, they can see the triangle, they can see the cone, right? Similarly, when they rotate the triangle about its hypotenuse, right? About its hypotenuse of the right angle triangle, they will get the double cone. So that also we can make them to visualize. Okay, shall I show one video for that? 1 second, I'll show the video.
Yeah, ma'am.
Are you able to see this? So
Yes,
here,
ma'am.
right angle triangle is there, and about the axis, about the perpendicular, we can place a stick. And here they use the mortar, and there they place one stick like thing, rod like thing. And now you can see, we can show them. So when you rotate the triangle above this perpendicular, it looks like the cone. So like that, we can give some example. And similarly, when we rotate the right angle triangle above its hypotenuse, we can ask them what kind of the figure you can be seen. So if they are not able to understand, we can take the right angle triangle, we can place the stick along its hypotenuse and we can rotate and show it. If you are able to show this video, they would be understanding very well. Yes. So now, here, they could see the double cone. So like this, we can show some video. Sorry. And we can give the link to them so that they will understand it very clearly. Yeah. Okay, teachers, we have seen the cone. So next we have the sphere. And sphere, most of the time, we are not doing this activity. Is it right? In the class 10 level, we have to make them to understand that is surface area of the sphere is 4 pi r square. Just what I am doing in the class, if you're not able to get these things means, I'm just telling that you have to take the sphere and take the thread and put one nail and you have to wind the thread around that sphere and completely you have to wind it. Then you have to draw 4 circles that is equal to the radius of the sphere. Then unwind the thread and you have to spread the thread like spiral way. You have to paste the thread on the 4 circles. So if you paste it, then whatever the thread you have taken to wind the sphere, that will be exactly fill the 4 circles. Therefore, we can understand surface area of the sphere is equal to area of 4 circles. That only usually I used to tell like that only. But if you show this video, surely they will be understanding the concept very well, I feel. So just you will see the video. Are you able to see the video? The important part I will show you here.
Yes, ma'am.
So what are the materials required for this activity she has taken? So first, she will be finding the diameter of this sphere. So she's helping how to find the diameter of the sphere. Surely we'll be having the WhatsApp group. We can send this link so the children will see in detail how to find the surface area of the sphere.
As you can see in this model, we have placed 2 cardboard pieces parallel to each other, and in between is the sphere. And this is the scale. The distance between these 2 cardboard pieces, as you can see, is nothing but 7 centimeters. So, diameter is, let us denote it with D. Like radius, 3.5. Now what we have to do is, on the surface of the sphere, we have to on any part of the sphere. The thin thread, we have to cover the sphere completely. Such a manner that no space.
So she's applying the glue over that and she's winding the thread. So it has to be done like that.
Take a sheet of paper and paste it on the cardboard. With the help of a compass, open the compass up to 3.5 centimeters.
So she's drawing the 4 circles.
The area of all circles 3.5 centimeters.
So radius of the circle is same as the radius of the sphere. So like that we can help them to understand how to find the surface area of the sphere.
Start filling this thread in these regions. In these regions.
So we have to unwind the thread and we have to fill the circles. So whatever the thread used to wind the sphere, that will be exactly fill the 4 circles. That is the idea behind this. So she is filling the thread. So she's filling the thread
Again,
in the spiral manner.
thread in such similarly, 4 as the square is 4 pi r square. This is the sphere, and the surface of the sphere is 4 times the area of 1 radius of 1 centimeter. This verifies.
Yeah, so this is given in our book also. Yes, teachers? Have you done this activity earlier? But it will take more time to work it out. So in class, it's not possible to do it.
Ma'am, I have an add-on point. I have tried this same method
Yes,
using an orange. Orange almost
Spherical
if you
orange.
spherical only. So you try to find the radius in the same manner. Then you can peel that outer layer of the orange and you can fill these 4 circles with these
Yes, ma'am.
outer layer. It will be more easy and we can show in the class easily. We
Yes,
can
ma'am.
tell everyone to bring one orange and try to do that also.
Right, ma'am. That is also
Yeah.
a good idea, ma'am. We can follow that.
Yeah.
Yeah, that we can do it. Or we can use thick thread. Instead of thin thread, we can use thick thread so that easily 4 circles would be covered.
Yes.
Thank you, ma'am. Yes, we can do it. And another thing, and it is not given in our textbook, finding the volume of the sphere. So let me show that video also. And I found it's a very, very interesting and the easier one also. 1 second, let me show that. Yeah. So finding the volume of the sphere, we usually how to find the volume of sphere means in a textbook it is given, we have to take a different sphere and that to be put in the in a cylindrical vessel full of water, and how much water it's coming out, that would be always equal to the 4/3 pi r cube. But here it's very, very simple to understand the volume of the sphere, that is equal to the volume of 2 cones. Provided having the same radius and height of the cone is same as the diameter of the sphere. So please see this. Like that we can make them to understand how to find the volume of the sphere. The cylinder volume is base area into height, pi r square into h. And volume of the cone is 1/3 of the volume of the cylinder, provided having the same radius and the same height. So the condition we have to tell. Now, volume of the 2 cones, that is equal to the volume of the sphere. This you can show it, children will understand it very easily. Volume of the 2 cones equal to the volume of the sphere. So 1/3 pi r square h plus 1/3 pi r square h. And here h is same as the diameter of the sphere. Height of the cone is same as the diameter of the sphere. So replacing h as 2r. Replacing h as 2r. So replacing h as 2r, you could see here, that will be equal to 2 pi r cube by 3 plus 2 pi r cube by 3. That is equal to 4/3 pi r cube. So volume of the cone is 1/3 of the volume of the cylinder, and volume of the sphere is equal to 2 times the volume of the cone, provided height of the cone is same as the diameter of the sphere. This you could try, teachers, so that easily they'll recall all the formulas. Right? So volume of the sphere is equal to 2 times the volume of the cone, provided height of the cone is same as the diameter of the sphere, and the radius of the cone is same as the radius of the sphere. When you take like that, easily we can make them to understand that the sphere volume is equal to 2 times the volume of the cone. Yes? So now we'll go to the slide. So like that, we can make them to understand surface area of the sphere and the volume of the sphere. Then the hemisphere is half of the sphere. So easily they can do by themselves. So volume of the hemisphere is 2/3 pi r cube, half of the volume of the sphere. Similarly, third surface area also half of the surface area of the sphere, that is 2 pi r square. And total surface area, they have to include the base area. Therefore, total surface area is 3 pi r square. Like that, we can help the students to understand. And then also we have to help them to understand the total surface area and the volume of the hemispherical, hollow hemisphere and the hollow sphere also. So both we have to do at the last. So once we are teaching the concept, we can do up to this. Once we are going for the revision, we can help them to understand how to find the total surface area of the hollow hemisphere, and also how to find the total surface area of the spherical shell, volume of the spherical shell. These things we can make them to understand. And the frustum we don't have this here. But anyway, the frustum is one of the important part, right? So frustum is nothing but the part of the any solid. And here in our class 10th, we have the frustum of the cone. So like that, we can do some experiment with taking the cone and cut the cone parallelly with the base. So we'll be getting the frustum of the cone, and the derivation as usual, we have to do it here also. Volume of the frustum of the cone, there is the CSA of the frustum of the cone and the TSA of the frustum of the cone. So everything it is given in the book. So this should be taught, and this time we don't have the frustum, right? And the next thing, we can use some activities to reinforce their learning. So this I have taken. That is, we can give the 3 cubes to 3 cuboids to them and having the same volume. All 3 cuboids having the same volume, and they have to, there is the real world contest. They have to find which design they have to take so that they can use the least material to make the cuboid. So they have to make the cuboid, which will be requiring the least material and also which is the most economical. So in that way, we can give some activities. So where there is the occupying the lesser surface area, that is the most economical one. So like that, they have to find the total surface area of the each design, and where they are getting the least total surface area, that is the most economical. Like that, they can proceed it. Okay, the small activity, I'll forward it to you. This you can use it for that, for your students, and this they will take it for the portfolio also. And then the next one, very, very important concept here is the making the children to understand 1000 cubic centimeter equals to 1 liters. Could you tell me, teachers, how you make the students to understand this concept, 1000 cubic centimeter equal to 1 liters? Will you be doing some activity based on this? So they have the conversion, right? Converting the cubic centimeter to the liters, cubic meter to the liters, isn't it? So 1 meter cube equals 1000 liters. So they have to do the conversion in many of the times. In class 10 and class 9, we have many questions based on that. So how you would make them to understand? We can do the small activity to make them to understand, right? We can take the cube with 1000 centimeter cube. That is, the edge of the cube is 10 centimeter. If the edge is 10 centimeter, the volume is 1000 centimeter cube. So we can take 1 liter bottle water and please pour in that. So it will be exactly filled. You can show this. Children will understand very clearly that 1000 centimeter cube equals 1 liter. Please do this activity. It's very, very simple to do it. Okay. And I'll send the video also because we have only less time. I'll send this video link. If possible, you can send this link also very clearly. That will register in their mind 1000 centimeter cube equals 1 liter. And also they'll understand 1 centimeter cube equals 1 ml. So what I usually do is after explaining about this conversion, I'll ask them to take the water bottle and they have to find the capacity of the water bottle. So what they used to do means they find the volume of their water bottle. Usually children, they'll be having the cylindrical water bottle only. Most of them, 98%, 99%, they'll be having only cylindrical bottle. Approximately, I'll ask them to find the total size, that is the volume of that bottle. So they used to find the volume. First, they will find the radius. To find the radius, they'll find the circumference of the bottle. From the circumference, they'll find the radius. And using the radius and the height, they'll find the volume. And suppose if they get the answer 843 centimeter cube. So 843 centimeter cube is equal to 843 ml. So surely the answer will be 1000 centimeter cube. That is a 1 liter bottle means they'll get the approximately answer 1000 centimeter cube. Like that, they can visualize, they can realize the fact that is 1000 centimeter cube is equal to 1 liter. So we can do one simple activity. If it is not possible, you can send the link to your students to the WhatsApp group. They can see that video and please ask the children to find their capacity of their water bottle. So easily they can cross check also because they all know the capacity of their water bottle. Just they have to find the volume. That volume would be approximately equal to their capacity, right? So this activity, children, they liked it. I have done this. So next one in class 10, why it is so important to find the combination of the solids. So this we have to tell them, we have to give many more examples why the combination of the solids are very, very important, right? So now In this also volume, they usually find it very, very simple. Suppose if they want to find the volume of this ice cream cup, means it's cone with a hemisphere. So they know very well volume of the cone plus volume of the hemisphere gives the volume of the total ice cream cone. That they would be able to understand very easily. Similarly, if they want to find the volume of this pencil, they can understand volume of the cylinder plus volume of the cone plus volume of the hemisphere. Sum it up, then we will be getting the volume of the pencil. So volumes are very easy to understand, but where they generally make the mistake means in finding the surface area of the solids. Isn't it, teachers? Yes, finding the surface area, because suppose scooping out some part or whatever the faces they are seeing, they find this very, very difficult. For example, if you see this particular one, here we have placed the hemisphere on the cube. So what is the total surface area of the block, whatever they are seeing? So for that, we have to give the solids, okay, place the hemisphere on the cube and give it to them and let them find what is the total surface area of the solid. Like that only, I have the many different solids in the wooden thing. And using that, I'll place the solid one over the other. I'll give it to them. They will visualize it and they will say what to do with the total surface area of the block, whatever they are seeing. So like that, we can do it. And here it's very, very important. Here they can see only the 5 faces of the cube, but the top face, they can't see the complete square part, because we have placed the hemisphere on this. The circular part is hidden. That they have to understand. So they have to subtract that circular part because it is hidden, and they have to add the curved surface area of the hemisphere. So when we show the solid only, children, they would be easily understand what to do. And also converting the one solid to the other solid, changing the shape from the one shape to other shape, that we can using the clay and we can reform the shape and we can show it. So the same amount of the solid, we are able to make the 2 different solids. So both the volumes are equal. So like that, we have to equate and find the unknowns. So we have to give more number of the examples, and also we have to show the solids of the combination to make them to understand the surface area or the volume very, very clearly. Right? Then the general misconceptions in the surface area and the volume that we have to talk. So the ratios, they are making a mess in that. For example, in this question, you see, given the ratio of the radii of the 2 right circular cylinders, 2:3. What they used to do means R1, 2x, R2, 3x. If they take like this, okay. Generally, what they do, R1 is 2, R2 is 3. Isn't it, teachers? Are they taking it like that? Is it correct? Can they take it like that? R1 equals 2, R2 equals 3 in this ratio problem?
No, ma'am, no. It's like
absolutely wrong. And many times, yes, ma'am, please tell me. Many a times we have seen this kind of the representation. Even though they get the correct answer, they will get the correct answer here if substitute as this, because the terms would get cancelled here. Okay, even though they get the correct answer, we should not award marks for this absolutely wrong concept. 2 and 3 are just the parts. It is not units, right? It's just the parts of it. So we have to make them to understand. Another thing here, the ratio of the radii, that is also in the terms of the 2:3, and even the height also in terms of the ratio. So for the both, they will take the same thing. R1 equals 2x, R2 equals 3x. H1 equals 5x, H2 equals 4x. Is it right? Is it right taking like this?
No, ma'am, no, ma'am. We have to take another variable, 5y, 4y.
Another variable, because they won't be having the same common multiplier, right? Yeah. They may have the different common multiplier also. They would be getting the correct answer. Please don't award the mark. Make them to understand what is the ratio. They should not use the same variable here. They have to use the different variable. Please make them to understand this part. Okay, they would be getting the correct answer, right? Even though they get the correct answer, don't award the mark. Tell them the common multiplier should be the different. It won't be the same radius and the same height. Same multiplier will not be there. So we have to use a different variable. And very, very blunder mistake is taking like this, R1 equals 2, R2 equals 2. Even we can see this mistake in the trigonometry also, right? Trigonometric ratio also, just like that, they will take it. So that is sin theta equal 3/4 means they'll take opposite 3 units adjacent hypotenuse 4 units, isn't it? So they should not take it as it is. That is only the parts we have to make them to understand. It's a very, very general misconception in the, not only in surface area and volume, where the ratio comes. Everywhere they are doing the same mistake, and the problem with the scooping out. Scooping out is a very, very big headache to the students. They won't understand. Scooping out means immediately they will subtract that part. It is not subtraction. So we have to tell them what are the faces you are seeing. Suppose when I give the solid like scooping out the hemisphere in the tube, where and all you will paint it. You just ask it, where and all you can paint it, tell me. So those faces area and all you have to add. That is the surface area you are seeing in this. These are the faces you are seeing in that. All the faces, whatever you are seeing, whatever you are going to paint in that, everything we have to add. Like that, we have to show the solid and make them to understand. Generally, the problem here is scooping out means they will just do the subtraction, right? Many students, even the good students also, they used to do this mistake. Isn't it, teachers? What is your point in that? They used to do this mistake, right? Have you seen this kind of the mistake? It's a very well-known problem in the class 10, right? Scooping out the hemisphere means...
Scooping out and converting into another solid, both they used to have the same kind of problems.
Right.
From one shape to another shape, the conversion also, they used to face a similar problem like this.
Generally, they won't add that hemispherical part. They'll just subtract it because scooping out, right? So this we have to make them to understand. Please show the solid and make them to understand, right? And the very, very biggest problem in the surface area and the volume of the class 10 is this problem. What do you think, teachers? Tell me, what is your opinion in this? The problem based on the water flow, right? What do you, please tell about your view? I found it as very, very mischievous, misconception in this part.
Actually, what's the problem we used to face in this kind of problems is, there are so many calculations. They won't have any direct answers for this formula. If you substitute, you will get answers like that. There was little bit many conversions like from hours to minutes, and they are supposed to think properly. It's not just like substituting those things directly. So they might find very difficult. First of all, they won't understand it's a cylindrical thing. It's coming out the cross section things. And they find difficult, or probably they used to find difficult over this.
So what we can do here is we can give some simple example, make them to understand, and then we can do this problem. For example, your water tank capacity is 2000 liters. Your water tank capacity is 2000 liters. And we are just switching on the motor, and the rate of water flow there is the 50 liters per minute. Then what's the time taken to fill the tank? Like that, give the direct volume and make them to understand how to find the time taken to fill the tank. Please give the simple example, and then we can go for these kind of the questions. Surely children will be able to tell. So 2000 liter by 50 liter. So total capacity of the tank divided by the rate of water inflow. So 2000 by 50. They will give the correct answer. What's the time taken to fill the tank? Then you give some dimensions about the tank, and then you give this exam, and then give the rate of water inflow. Then they will using the dimensions of the tank, they will be able to find the capacity of the tank, and then they'll find the time taken. Like that, slowly you can incorporate the concept. First, you give the volume of the both. First, you give the volume of the tank and the rate of water inflow in terms of liters. And then you can give dimensions of the tank, ask them to find the capacity, and then the time taken. Then you can tell the water is flowing through the pipe, and you will tell, since the water flowing through the pipe, water takes the shape of the medium. So those concepts we have to tell. Then we can give the dimension of the pipe, and also we can give the dimension of the tank, and then we can ask them to tell what's the time taken to fill the tank. Like that, step by step, if they tell, surely they will be able to understand this part. Right? Last but not least, we have here the case study question. So surely we are getting some case study question based on the surface area and volume. Yes, the question here, what is mean by case study question I have taken? Case study is just a scenario in a particular professional context which students are expected to analyze. They have to analyze and respond to guided by the specific question posted concerning the situation. In many cases, the scenario or the case study involves a number of issues or problems that must be dealt with in a professional workspace. So case study question, they have to read the question very carefully. Whatever the person posted, they have to look at the dimensions given based on the case, based on the particular problem, and then they have to link with the concept whatever they have done. Linking is very, very important. Whatever the concept, whatever the formula they have studied, they have to link with that, and then planning the solution is very important. So I have taken the one case study, and this case study, they found it very interesting. And here, this is not a direct formula. If you see this question, I think you would have been come across this question. Have you teachers? Have you come across this question? This question about the tunnel. So tunnel, they have to find the how much volume of the earth is removed to make the tunnel. So actually, first they have to make the cylindrical. Then only they can put the rail over there. So first they have to take out the cylindrical part from the tunnel. So to make the tunnel, they have to excavate the earth in the cylindrical frame, cylindrical form. Okay, so how much volume of the earth is removed means they have to find the volume of the cylinder, that they are able to do it. But please, teachers, I would like to hear your answer for this. Just 2 minutes time. 2 minutes time. Just look at the third question alone. A coating is to be done on the surface of the inner curved part of the tunnel. That is, this is the inner curved part of the tunnel. Are you able to see? This is the inner curved part. So this is the inner curved part, and they have to find what is the area of the tunnel to being coated. So coating to be done only for this place. Okay, only for this place coating has to be done. That means what is the area of the tunnel to being coated? Can you tell me how will you help your students in this question? Coating to be done only to the inner curved part. This is not the exact figure whatever they are learning. So what about this shape? How would you help the students to understand this? So coating has to be done here. They can work like the prism. So this is nothing but the circumference of the sector, right? Length of the arc. Isn't it, teachers? Length of the arc. So length of the arc they can find using the area of the circle, that concept, area of the sector concept. There is 360 minus 90. 270 is the angle over here. So 270 by 360 2 pi r. Can you mute yourself, ma'am? Please, Jayalakshmi ma'am. Could you please mute yourself? So they can find the length of the arc. 270 by 360 into 2 pi r. They can find the length of the arc. Length of the arc into the height, length of the tunnel, which is a 450 meter given. Length of the arc with the length of the tunnel. So when they do that, they will get that the lateral surface area of the tunnel. Isn't it? Only this part. So from that, they can easily find the area of the tunnel to being coated. So this I found is very, very interesting. That's what we have to give more importance about the prisms, finding the volume of the prism and also the lateral surface area of the prism. If they understand that, surely they can do this problem.